Alright, now we're going to talk about a specific type of function, linear functions. This is section 2.2 from your book. So a linear function is a function whose graph is a line. Makes sense, right? You can represent a linear function with a linear equation, such as y equals 2x plus 3. What do you think the solution to a linear equation is? The solution's an ordered pair. So remember, solution is a value or values for a variable that make the statement true. So in this case, you have two variables, so you need two values that make the statement true, an input and an output value that match each other. So the solution to an equation like this is just one value, x equals something. But when you have a line, the solutions are ordered pairs. They come together. Alright, and we also say that because the value of y, the output value, depends on the value of x, it depends on what you put in as to what you get out for y. Y is called the dependent variable because it depends on what you put in with x. X is called the independent variable because you can pick any x value you want and plug it in here and then as your input. So this is because we're talking about it in terms of a function. You might be thinking, well, I could pick a y and then solve it for x, right? Well, yeah, you could, but when it's a function, it's really important that you specify what is your input and what is your output. So you really need to make this distinction between dependent variable and independent variable when you're dealing with a function. Okay, let's go ahead and graph a linear equation. So to graph a linear equation, all you need is 2 points. Okay, so you can plug in a point for a value for x and get an output value for y. So let's make a little table over here, x, y, and let's plug in a point for x. Well, I'm going to plug in an easy point, so I'm going to plug in 0 for x, because if I plug in 0, I get 2 times 0 over 3 plus 3. This is going to cancel out, and I get y equals 3. So that was fairly easy. I pick easy points because it makes my life easier. Okay, now I could pick like 1 for x, but then that would give me a fraction. I would get 2 over 3, and I don't like fractions. So I want something that's going to cancel out and give me something that isn't a fraction. So I need something that makes this 3 go away. So I'm actually going to pick 3 for x, because now I do 2 times 3 over 3 plus 3. The 3's cancel, and I get y equals 2 plus 3, which is 5. Okay, now I have two values. I have an x value and a y value. I have two different ordered pairs. Now I can graph a line. All you need is 2. So the point x is 0, starts at the origin and goes up to y equals 3. So this is the point 0, 3. And then go over 3, up 5. This is the point 3, 5. And now I can graph this line. I'm going to use a line tool. Goes through both the points. Alright, so that is my graph of this equation. You just find 2 points and then you can graph it. That's all you need for a line. Okay, let's talk about some of the characteristics of a line. Some vocabulary. A y-intercept is the place where the line crosses the y-axis. So the vertical axis is the y-axis, and the place that it crosses is a point. It's some point where it crosses, and it's always a point 0, something. Okay, so 0 because the x value is 0 at the y-intercept, and then we don't know what the y value is. But it's just important to remember the y-intercept is a point, an ordered pair. It's not just one value. Okay, the x-intercept is also an ordered pair. It's where the graph crosses the x-intercept, and that's at some point, 0, some value, 0, because the y value at the x-intercept is 0. Alright, standard form of a linear equation, ax plus by equals c. A, B, and C all have to be real numbers in there where A and B are not both 0. Why can't A and B both be 0? Well, if A is 0 and B is 0, then what we have is 0, because 0 times anything plus 0 times anything is 0, equals C. So we know 0 equals 0. Well, that's cool, and you could maybe like draw a smiley face out of that, but it doesn't actually create a line. There's no line, it's just one value. So, it's really important that A and B are not both 0. A good way to remember what standard form looks like is both of the variables are on the same side of the equation. Okay, so standard form of a linear equation is what? I want you to pause the video and try and see if you can write down what standard form is. And standard form is ax plus by equals c. A, b, and c are just numbers, they're placeholders. X and y are variables that won't change. So like I said before, this is an example of a linear equation in standard form. Okay, real world connection. Let's do this example. We have some equation here that models the number of passengers who can sit in a train car. X represents the number of adults that can sit in a train car. Y is the number of children. We're going to graph this equation and then explain what the x and y intercepts represent, and we're going to describe the domain and range. Alright, so this is in standard form. The x and the y are both on the same side of the equation. In this case, they're both on the left side of the equation. The best way to graph something that looks like this when it's in standard form is to plug in 0 for x to find the y-intercept. So if I plug in 0 for x, that's right here. When x is 0, it's going to tell me where does it cross the y-axis. So plus 2y equals 120. This reduces to 2y equals 120 and y equals 60. So we got the value 0, 60. That's one of the points on our graph. That is the y-intercept. Okay, now let's do the exact same thing, but this time let's find the x-intercept. Well, the x-intercept is where y is 0. When y is 0, it crosses the x-axis. So I plug in 0 for y, and I get 3x plus 0 equals 120. So 3x equals 120. Divide both sides by 3, and I get x equals 40. So when y is 0, x is 40. So here are my 2 points, and remember you only need 2 points to graph a line. That's all you need. It's very nice. So I'm going to use my line tool, and I'm going to come through these 2 points. Okay, so there's my line. So we've done the first part, graph the equation. Second, we need to explain what the x and y intercepts represent. And then we're going to describe the domain and range. Well, what does this value represent? 0, 60. What is it? And this one is 40, 0. What do they represent? Well, let's look at what x and y represent. X is the number of adults, y is the number of children. So here you have 0 adults and you have 60 children. So this represents how many children could fit on the train if it was only children on the plane, 0 adults. This is the opposite. You could fit 40 adults on the train if you had 0 children. So it kind of shows the maximum for each variable. The maximum value that y could be in this case is 60, and the maximum value that x could be in this case is 40. So actually, because this is a real-world context problem, I'm going to draw my line a little bit differently. I'm going to use a line segment to show that really it's only the values on this line that go up to the intercepts that are possible, because I couldn't have, if I went farther this way, I would have negative adults. I can't have negative adults on the plane, and I also can't have negative children on the plane. So this actually makes a lot more sense. Describe the domain and range. Okay, that's going to help us in describing the domain and range. And let's look at why. The domain is all the input values. They're the x values that are possible. Well, in this case, a negative x value doesn't make any sense, so it's really not a possible input value. So 0 is the lowest possible x value that it could be. And here we see the maximum x value that we can have is 40. So the domain in this case is any x value between 0 and 40. It can be these decimal numbers, so you don't have to write them all out. It's actually impossible to write them all out. I couldn't write 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or 0.1, 0.01, 0.001. You can't write out all the values. So then if you can't write them all out, you have to do something that represents it, like this. The x values between 0 and 40 are my domain. My range are going to be the y values. And in this case, y can't be less than 0 also, and they're going to be between 0 and 60 for the range. So here's my domain and my range. I've described what they represented, and there is your line. Okay, now let's talk about slope. So slope is a really important concept in math. It's pretty much what calculus is all about, slope, because slope is a rate. And in our case, it's the rise over the run. It's how fast is it changing in the y direction for every one that you go over in the x direction. The way that you calculate slope is you use this formula. You figure out how much does it change in one direction, in the y direction, and how much does it change in the other direction, in the x direction. So how much does it change vertically versus how much does it change horizontally? Again, in algebra, anytime you have division, you can't have 0 on the bottom, so we have to specify the x points can't be at the same place. This is another way of saying it. If they're in the exact same place, we have a problem. Let me show you an example of that. Okay, if I had a vertical line right here, like this, and I was trying to calculate the slope between these 2 points, I would have the exact same x value. So let's say this is 1 and this is 3. And then it's crossing at 1 for x. So we have the points 1, 3 and 1, 1. Now you should remember this would not be a function, right? We'd have a problem here because we have one domain value going to 2 range values. So what we want to do is we want to calculate the slope. The vertical change is easy to calculate. You do 3 minus 1 over 1 minus 1. The y values minus the change in the y direction over the change in the x direction. And you get 2 over 0, which blows up algebra. And that makes sense if you look about it in this case. This line is vertical, so slope doesn't really make sense to talk about there. There's no such thing as a vertical slope. Okay, find the slope of the line through these 2 points. So the first thing is we got to figure out what is our x and our y. X is the first value, y is the second value. The change in y goes on top. So let's do -2 minus 6, our 2 y values, and then our 2 x values, 3 minus -9. -2 minus 6 is -8. 3 minus -9 is the same thing as 3 plus 9, which is -8 over 12. And let's go ahead and reduce this to -2 over 3. This is our slope. Okay, so you might be thinking, did it matter that I did this one minus that one? I thought that it said y2 minus y1 in the slope formula. It does. Let's look at what happens if you do y2 minus y1. 6 minus -2 over -9 minus 3. Okay, I just switched these. I did 6 minus -2 and -9 minus 3. 6 minus -2 is the same thing as 6 plus 2. -9 minus 3 is -12. So then I get 8 over -12, which is 2 over 3, -3. These are actually the exact same thing. 2 over -3 and -2 over 3 are both -2/3. So it actually doesn't matter which order you do it in. But what is important is that this is an ordered pair and this is an ordered pair. Oh no, I was supposed to have changed the color, but for some reason it's not taking. Okay, the x3, -2, that's a point, and -9, 6 is a point. So what really matters is that they're lined up. Okay, so I should actually switch these colors on bottom, but I think you get the idea. I hope. All right. Next form that we're going to talk about is point slope form. Just as a quick reminder, what was standard form? Standard form was ax plus by equals c. So this is the first form we talked about. This is the next form that we're going to talk about. They're really useful for different things. Standard form is useful for when you have problems like what we had with the adults and the children on the train. Or if I was going to say shirts cost $10 and pants cost $5, and I'm trying to figure out how many different shirts and pants can I buy if I have $100. It's really nice to be able to just write that equation out just like that. So standard form is really useful for some things, but point-slope form is useful for other things. This is the equation of a line that goes through this point, and here are the values for that point, and has this slope, m. So if you know a slope and a point, then this is the easiest way to write a line. Let's do an example. Write in standard form an equation with the slope through the point, 8, negative 1. So in this case, we are given a slope and we're given a point, so point-slope form makes a lot of sense to use because we can just plug it straight in. If I tried to do this in standard form, it would be kind of difficult because standard form doesn't have m written out anywhere, a slope. Okay, so I'm going to plug in our values. y1 is this value right here, negative 1. Slope, m, is negative 1/2. Then I have x minus x1, which is 8. Okay, notice I left the y and the x in the equation. We really need those or you don't have an equation of a line. Y minus negative 1 is the same thing as y plus 1. And I'm done. This is the equation of a line in slope or point-slope form. And I don't have to, simplify it or write it in standard form or slope-intercept form, which is what a lot of you are used to when you see a line, which we're going to talk about now. Oh, no, one more example before we do that. Okay, so what about if you just have 2 points? What do you use? Well, we can use slope-intercept form. I mean, not slope-intercept form, point-slope form. We just got to figure out what the slope is. So let's calculate the slope from these. 5 minus negative 1 over 1 minus 4. Notice I did it I did x1, y1 first, but it doesn't matter because the 5 and the 1 are matched up with each other. The 4 and the negative 1 are matched up with each other, so this will give me the correct answer. That's 5 plus 1 over negative 3, which is 6 over negative 3, which is negative 2. So our slope is negative 2. That's what m is. All of this is what m was. So now let's go ahead and plug in and get our answer. I'm going to do it in red. Y minus y1. I'll go ahead and use this one. 5 equals our slope times x minus x1. Again, really important that I use the same ordered pair here. Here's one of the solutions. Here's another solution. Y minus, I could have used this y value. Negative 1 is equal to negative 2 times x minus 4. These are actually the same equation. It doesn't look like it, but if I was to write this out in standard form, I would have the exact same equation. So both of these are correct answers, but it's just really important that you use 1 and 5 or 4 and negative 1. Okay, slope-intercept form, y equals mx plus b. This is what people are most used to seeing when they have a line. It's really useful for graphing because you have a y-intercept. If you have something in this form like we did with the first problem, you can just go up to the y-intercept at 3, and then you can go by your slope. The change in y is 2, up 2, and the change in x is 3 over 3. And so you have that point, and you can graph it. It's really nice to graph. For graphing. So if you're supposed to graph something, often the easiest way to graph it is to put it in slope-intercept form. The slope is the value that goes with x. So if you have something that looks like this, the slope is the part that goes with x. The slope is negative 2. The slope is not negative 2x, it's just negative 2. It's the coefficient of that term. And then the y-intercept is the other part. Alright, let's do an example of this. Find the slope using slope-intercept form. So what form is this in right now? The x and y are both on the same side of the equation, so this is standard form. We're going to find the slope by solving for y. If you put it in slope-intercept form, you can see what the slope is just by looking at what's in front of x, but in order to do that, you have to solve for y. So let's go ahead and do that. Let's get 4x on the other side. We now have 3y is equal to negative 4x plus 7. Divide everything by 3, and you get y is negative 4 over 3x plus 7 over 3. So now we can see what our slope is. Our slope is m, it's the coefficient of the x term. So it's this. Our slope is negative 4 over 3. Alright, so here are the different equations of a line that we have so far. We have point slope form, where you have y minus y1 is equal to m times x minus x1. You have standard form, where both variables are on the same side of the equation. And you have slope-intercept form. Like I said before, these are really useful for different things. Standard form is useful for real-world type problems. Slope-intercept form is really useful for graphing because you can see the slope and the y-intercept immediately. Point slope form is also good for graphing because you have the slope and you have one other point available here. It's also good for finding the equation of a line easily if you have 2 points or if you have a point and a slope. So here, these are all actually the exact same equation, just written in different forms. So the red, green, and blue are all the same equation. Alright, let's talk about some different types of lines. There we go. Vertical line. I'm not sure why it was doing that, but a horizontal line is written in the form y equals something. So if I wrote the line y equals negative 1, I would come down negative 1 and I would graph a horizontal line. It doesn't matter what the x value is. If the x value is negative 1, y equals negative 1. If the x value is negative 2, y equals negative 1. So that's why you write it like this, y equals negative 1. There's no x in this equation of a line, because for all x values, y equals negative 1. Okay, vertical line, same thing, but different variable. If I said x equals negative 1, I would come graph that line right here. It doesn't matter what y value I'm talking about. If I'm talking about 0, x equals negative 1. If I'm talking about 1, x equals negative 1. It doesn't depend on the y value, and that's why it's a vertical line. X always equals whatever that value is that it crosses the x-axis at. Okay, perpendicular lines are two lines that meet at a right angle. This is going to be really useful for some of the types of problems that we do in class. There's a right angle here, and the slopes are actually, if you multiply them together, you get negative 1. A different way of saying that is the slope of one of them is the opposite reciprocal of the other slope. So if I had this line, 2/3 x plus 3, the slope of its perpendicular line would be the opposite reciprocal of 2/3, which would be negative 3 over 2x plus whatever its y-intercept was. So the slope is the opposite reciprocal. That's how you know that they're perpendicular lines. It means they meet at a perfect right angle. Okay, the other type of line that we're going to talk about that's interesting is parallel lines. And parallel lines never cross each other. And that's because they always have the same slope. They never get any closer to each other. This distance stays the same forever on both sides. They have different y-intercepts and they have the same slope. So 2/3 x plus 3 and y equals 2/3 x minus 4. These are parallel lines. They're going to cross at two different places, but they're going to keep going in the same direction forever without ever crossing. So let's go ahead and do an example of this. Write an equation of the line through each point and perpendicular to this. If it's perpendicular to this line, that tells us what the slope is. Remember, a perpendicular line, if this is one slope, then the slope of the perpendicular line, I'll just write it with m with a little p down here, is the opposite reciprocal. So negative 4/3. So we already know the slope of our line. In this case, it gives us a point that it goes through. So you need to graph a line, you either need 2 points or you need a point and a slope. So I could use point slope form because I have a point and a slope, x minus x1, and I can plug these values in. The y value is 4, the slope is negative 4/3, and the x value is 0. I could write it like this, but another way to write it would be like this. Okay, if you solve this equation for y, this is what you get. I could have gone straight here by using slope-intercept form because I know the slope and I know the intercept because this is the intercept. When x is 0, it crosses the y-axis at 4. So I could have written it in slope-intercept form, but this is the correct equation. Either of these would work, actually. Alright, let's do another one. Well, if it's perpendicular to this line, we know the slope again. Slope of the perpendicular line is the opposite reciprocal of this slope, and it goes through this point. Now, this isn't an intercept, so it's easiest to use point slope form. M times x minus x1. So I'm going to plug those values in. The y value is 1. The slope is negative 4/3. And the x value is 6. So here we go. This is the equation of the line that goes through both. You don't need to change it unless it told you to write it in a different form. This is the equation of the line in point slope form. So you don't have to write it in slope-intercept form.